Session is being recorded right now. Just to verify it. Yeah, the red button seems to be on. Sorry, music. I didn't hear anything. Hello, everybody. Okay. So before we start, the test went quite well. We have a good spread with the marks. Looks like I guess some of our heads were smoking a little bit from overheating, which is good because that's when you learn. When your head is smoking, you're learning. Yeah, this was surprisingly hard. Well, I had to make it a little tiny bit harder for the online test, especially because it's open book, right? And there's no limit on time. But then again, you're learning. So a couple questions stood out, and thank you. A couple questions stood out for me. I might repeat those questions, but one thing was, let's say here is a. Let me just get rid of the mouse because you don't see it, but I see it. Yeah. Let's say here is a telephone set. Here, I'm just gonna. There's a telephone set here. And there's a line that is connected from that telephone into the outlet. Okay, now when the single line telephone set is looking for the line, where is it looking as far as connections? Which prongs? Because telephones use the USOC, Universal Service Ordering Code. We went over that. Now, which prongs is this telephone single line, which is just tip and ring? Which prongs on the outlet, according to USOC, is this telephone looking for? Anybody have any idea? This is important for us to know because that's the basics of the basics. Okay. So you might want to review some of the notes and the lectures, but I'm going to tell you right now. It is looking for the two middle prongs right here. That's the tip and ring, red and green, or white, blue, and blue line. Right? Physical connections, physical connection is the two middle prongs. And when you remember the USOC and actually T568 standard, when you look at the outlet, the first two prongs are the middle ones. And on the outlet, it is white, blue, and blue. And blue. I just used three-letter designations here. So that's where the phone is looking for the signal. The other ones for the single line are not used. It's just these two. Okay? Just these two prongs, two middle prongs, and they are connected to white, blue, and blue. Okay? Now, when you're bringing a telephone line, single line telephone, like a CO line, central office line, from outside, it has to connect to the white, blue, and blue. Here's the one line. It has to connect to the two middle prongs because that's where the telephone is looking for the signal from, those two middle prongs, and they happen to be white, blue, and blue. We did the 110 punch down, and we also did the plug, T568 plug, Rg45 plug. So the two middle prongs are white, blue, and blue. So if the jacketing of this cable is pink with red polka dots, it has to connect to white, blue, and blue. If this the color of this jacket is purple with yellow stripes, and the other one is green, it still has to connect to the white, blue, and blue, because that's where the two middle prongs are connected. If you have a Cat5e cable and the signal is brought into the jack on one of the pairs, whichever the pair it is, it has to connect to white, blue, and blue. If it's on the blue pair, white, blue, and blue, it goes to white, blue, and blue. If it's on the green pair, white, green, and green, it has to connect to white, blue, and blue, because it's internally in the jack, it is connected to the first pair, which is the two middle prongs. If it's on the brown pair, it still has to connect to white, blue, and blue on this jack. So is everybody clear on that one? I don't see any no's. So, okay, there's one yes. There we go. All right. So that's to clarify that question, because I've seen that these were the questions that most people were struggling on. Actually, pretty much everybody. So that was one common question that that stood out. The other question was, let me just get the tip and ring information here. I'm going to bring that thing on the main screen. Over here, what do we see here? Here's the tip and ring. Tip is the green, and red is the ring. So ring and tip. Tip is positive with reference to the ring. Remember that? That's one of the, I think 2-3 lessons back. We have this picture here. But now, so tip is positive with reference to the ring. But where's this ground here? Over here, we see that the tip is connected straight, right, to the ground. So the tip is positive with reference to the ring, but it is neutral with a reference to the ground. So the tip, the positive of these two, sits at the ground level, and the ring is more negative than the tip, but it is negative with reference to the ground. So we have to, that's a concept that really has to be understood. And the reason for that is that when in the old days, when they were running the telegraph lines, in the beginning they would run it in reverse to this. So basically, the ring was negative and it was connected to ground, and the tip was positive and it was positive with reference to ground. And when they, so what happens is that the lines, the telegraph lines or the telephone lines on the utility poles along the railroads and whatnot, they found that they were corroding a lot. So reversing the polarity, making the positive tip, which is when they made it day, okay, the quote unquote day, the technologists at that time, by making the tip, which is positive, to be equal with the ground, and the ring would be more negative, then those lines stay without corroding as much as if it was done the other way. Okay, so these were the two questions that really stood out. Okay, all right. So today, the next topic. Let's see what happens with our course plan here. Today is Friday, February 19th. We just had the test last week, and today we're going to talk about telephone systems, and we're going to cover two basic types of telephone systems. that are the conventional telephone systems and the VoIP, which is voice over IP. So this is going to be the first part of our class. This is going to be the second part of the class today after the break that we go for coffee. Okay. All right. So first thing, we're going to start. Cue it up. Oh yeah, by the way. Then we're going to cover the PA systems, public address systems, 2 parts. And then we're going to have a reading week after week 7. See the dates, February 26th is the next, a week from now. And then from February 26th. So from February 1st to February 5th, we're going to have a reading week. So that's going to be like our March break. Okay. All right, let me cue things up. Where's our PowerPoint? Here it is. Okay, here it comes. Now, if you noticed, I already posted Lab 6 on our YouTube playlist. Now, the first part, it's a long demo. It's actually about an hour and a half. And here's the thing. According to my predictions, and I think I'm right, when you leave the school, most likely you're going to get hired in this field, which would be installing wiring networks, for running wires for networks, connecting infrastructure, mounting devices on the walls, in the ceiling, in the floor, and so on. Yes, some of my demos are a little bit longer, but I think that if you spend that time, a little bit more time now, it's going to be that much easier for you later. I'm trying to give you as much as I can so you can find yourself comfortable in the real world when you leave leave our college. So I would encourage you to really go over, because the first part of the lab demo, Lab 6, which is the last one that is posted, Lab 6 on our YouTube playlist, it's also going to be part of the theory. And I wanted to throw that on there because our Zoom meetings or Zoom sessions, they tend to be tiny bit more blurry than we want to, simply because of Zoom is basically sharing the bandwidth. The more people log in, the more watered down the signal is. And there's nothing I can do from this end here. But when I did the demo, I am not doing this online. I'm doing it locally, recording it on a local computer. So the quality is much higher. And so that's why I wanted to have that part on the lab demo, but this is going to be part of the theory. All right, this is basically about the BIX platform, BIX punchdown platform. Okay. All right. So, sorry, there was a will test to be just on the weeks or everything. No, let me just get back to that here. Where is it? Here it is. Okay, so the test 2 is going to be just anything from now on till the PA systems. Okay, so test 1 was from whatever was there, and you know, some of those the content was the organizational kind of a thing, you know, how the class is organized and things. So I'm not going to test you on that. So that's why you see a little bit more content here. But the PAs, the telephone systems today, and the public address systems, that's all that's going to be covered on the test. Because of the new COVID-related changes that we have no final exam. So I used to have 2 quizzes and 2 tests and the final exam, but now after restructuring, we had to restructure the whole system. Then due to the COVID changes, then we're just going to have 4 tests: test 1, test 2, and the tests are going to be only on the content between the tests. So it's just going to be on anything from today till when the test starts. Okay. All right. Yeah. So telephone systems, and you're going to talk about the conventional telephone systems. Right off the bat, we have a picture with a whole bunch of equipment. So we have actually we have this this Nordics or Nortel system installed and connected in our classroom with a couple of telephones there, and the wires connected to the BIX platform. So just when you're there, just ask me to show you, and I'll just go over some details of how things are being cross-connected and connected in the real world. It's a smaller version of what you will probably be seeing in the real world. Well, probably for sure, okay? Because those systems are still there. Even if some companies switch to VoIP systems, they have a blended solution. So they still have the old infrastructure and they're getting the VoIP telephone lines, if I can call it that way. They get the SIP lines, okay? And we'll go over that, what that is, okay? So this one is 6 by 16, which means according to the Nordics or Nortel telephone systems, you can bring 6 lines in and you can branch out to 16 extensions. So 6 by 16. The smaller one here is 3 by 8, which means you can bring in 3 lines in and you can branch out 8 extensions. Both of those, this is mostly, this system was mostly installed in small, very small business scenarios. This one also small business, but when you need a little bit more extensions. Now, this is the same thing, but it's modular. So the way the system, these 3 operate, they operate in the same way. The only difference is the capability of connections. This is a modular system, which is right here. It's kind of blown up here. And you can add the modules, add, and whatever you're adding, you're bringing this thing onto the BIX platform. And that's how we're doing the cross-connecting here. And over here, we can see the Nortel telephone systems. Now, I just put the Nortel because these were the most popular ones that were installed. But don't forget, also there was a lot of popularity associated with the Panasonic systems, Toshiba systems, and whatever else. There will be a few other ones. Now, the way of programming and setting things up would be a little bit different with each brand or company, but the basic operations would be the same. The idea that how this thing has to work, the final effect, is the same, and we will go over that in the next couple of slides. All right. Now here are the telephones. These are something that's called proprietary telephone sets. What do I mean by proprietary? I mean that this telephone set right here is only going to work with this system, with the Nortel telephone system. If you plug it into the regular POTS line or the CO line, this telephone is not going to understand the signal. Right? Now, this system understands the telephone lines because you're plugging in those telephone lines into it, but the internal routing and the signaling is from then on is basically designed for the telephones. This is now here is the reception console or switchboard console, so that if you get the bigger telephone here with more buttons and more features, this would be the most of the time this phone would be at the reception, and it would be associated with or in conjunction with this switchboard. So these are programmable buttons, and they could be programmed to be extensions or features. Now, this would be a regular telephone set for just somebody who is working in the cubicle. They don't need all that many features, although some people requested to have that. And this is the smallest one. These telephones would be installed in lunchrooms, lobbies, foyers, the main lobby was you go into the building, and things like that. So we basically need to pick it up and have a conversation there. And all of those will be assigned an extension number. And pretty much you could use all the features that are from the system, and some of the telephones would have, you could call up a feature like, for example, all call page, or call transfer, or putting things on hold. Well, everything could be put on hold, and all those systems with a button. But these phones, they have less buttons here. You could still use those features, but you would need to know the feature numbers. All right, so it's like feature 981 would be something, I think would be a page, if I remember that. So you could press a button, and with a press of a button, you could just go and make an all call announcement, because this also connects to the PA system. All right. In this one here, you would not have the feature buttons, but you could press something that's called a feature button, and you could press feature, so and so and so, and then the feature would be activated, and you would get the pre-announced tone, and you could do the all call page, or do the, you could put someone on hold or whatever else, transfer the phone call. All right, so here, now these are the BICS frames, the BICS field. They're used to cross-connect telephone system into the telephone extensions, and we'll go over how this thing is done. And I encourage you to ask questions when you're in the lab, because we do have something like, we do have that set up, and I can show you the details of how this is done. Right? It's pretty neat, actually. Okay. All right. So terminology associated with the telephony. Right? We'll go over that. We'll go over these here. All right. So the first one here, where's my mouse? Here's my mouse. Okay. Pulse or tone. Okay. So pulse. This is the dialing. Remember when we were talking about a couple lessons back, the old rotary dial that was used well, not too long ago. The type of dialing would be done by sending pulses. You would interrupt the line or connect the line, and depending on what number you would dial, the dial would go back at this constant speed, and it would cause interruptions on the line, and the central office would recognize those interruptions, and it would recognize it as a number. Right? So that would be the pulse dialing. Now, the phone systems can be set up so when you press the buttons on the phone in your office, and this telephone set is connected to the telephone system, KSU would be key service unit, or PBX, private branch exchange. It's the same thing. It's basically a box that's sitting in the wall there. It's acting as a telephone system. You could program those lines in the line programming section of that telephone system. You can program so the telephone dials outside using the pulses or using the tones. So that's one, the pulse type of dialing that the system is going to use, or tone. It's a dual tone multi-frequency dialing. What that means is basically is that when you press the button, you're going to hear a funny tone. It's not just one single frequency. It is it's a combination of two frequencies, and just so the telephone system or the central office, whereas somewhere in the, somewhere down the street, can understand this thing as a number for sure. Because if it were just one frequency, you could have some background noises, radio playing or something else, and some of those, by coincidence, by accident, some of those frequencies that are happening from the background, or even from you talking, it could be mistaken as a number. So that's why, just to make sure that this button was pressed, it's looking for specific combination of two frequencies together, right? And that's associated with the terminology, something like, I didn't put that on. It's called breaking the dial tone. Okay, now when the pulse dialing, when you pick up the phone, this is the regular telephone, POTS telephone, you hear the dial tone, right? Now, how you break the dial tone is you start dialing. So with the pulse, as soon as it starts pulsing, the dial tone is broken, and it's silent, and so the telephone goes silent. It's just looking. It knows that you're dialing. Okay. Now with the tone DTMF dialing, as soon as you press the first button, that's how you break the dial tone. That means the dial tone goes silent, and the telephone system down the street or the central office is basically trying to recognize the numbers that you're pressing, and based on that, is going to route your telephone call. Okay. So now, most of the time, you're going to see the tone type of dialing. Now, here a word of wisdom when it comes to troubleshooting. When you're going to get a service call, like for example, the problem is described as such. Okay, we can dial out, but when we get to the destination, we're connected to whatever the client is, and there's an automatic type of routing there, and it says press 1 for this, press 2 for that, press 0 for the operator, whatever. Then it's not recognizing that. It's just not happening. Well, probably is because by some by some forces from Cosmos or whatever, the telephone system that's sitting in the wall of the client's business, somehow the telephone line programming, was switched to pulse dialing. And most of the central offices are still going to be able to recognize the pulse dialing, although some of them will not even recognize that. Technology goes forward. But even though they can actually pick up the number that you're dialing, but when you're trying to press the choices from the menu that is announced, press 1 for this, press 2 for that, and 3 for the other thing, then you're not sending the tones, even though you're pressing the numbers on your telephone that's sitting in the office, but the system is not sending tones, it's sending pulses. Okay, so all you have to do is just go into the telephone line programming and switch that type of dialing from tone to pulse. So sometimes it's a common, well, not that very common, but it happens once in a while. So just here it is. Now you know how to troubleshoot some of that telephone systems. Okay, now, loop. Okay, so we covered this pulse and tone dialing, right? Dual tone multi-frequency dialing. Okay. Ground start and loop start. We are using loop start. Okay, basically is what that had to do is in some of the old days, ground was being used as the reference, and you would just have one wire being pulled, and the ground was being as a reference. And that was not very efficient, but some of them you would have that type of connection there. But if you have loop start, that means that there's a whole connection looped. There's a wire, tip and ring. It goes from the central office to the telephone, wherever that is, and it's coming down to wherever it is connected. So it's a closed loop. When you see the line programming section of any telephone system, select the loop start, because that's what is being used right now. DoD, direct outward dialing or direct inward dialing. These are pretty common features. When you can select a button on your telephone system, you can program it so it's going to be direct inward dialing or direct outward dialing. Basically, what it means that if you have a telephone set on a desk and there's a button here, it's press that button, it's going to select a line and dial a number, right? Or if that will be direct outward dialing. And if you have another button programmed as direct inward dialing, you press that button and it's going to it's not going to select the outside line, but it's going to select the internal circuitry, and it's going to dial somebody's extension who is still in the same building connected to the same system, right? So it's one of those. I would encourage you to keep that list here of the features. Okay. Hotline. Okay, so hotline is direct inward dialing or direct outward dialing with a specific number dialed automatically. The difference between the DoD and the hotline, or DID and the hotline, is that when you want to use the DoD or DID, you pick up the handset and you press a button and the action happens. When you have a hotline telephone set up as a hotline, as soon as you pick up, that thing automatically dials a specific number. Where that thing is being used, some of those, like for example, there will be a company that would have a closed doors, and there will be a telephone sitting right in the lobby. So it would be like a foyer thing. You would enter the building and you would find yourself in a kind of like enclosed room, and the main door would be still locked to go inside, but you would have a telephone there, and it would there would be a sign says pick up the handset, right? So as soon as you pick up the handset, you would dial the reception. Hi, I'm here, I have an appointment and so, okay? And somebody would just come in and open the door for you. Another example of the hotline would be sometimes in large department stores such as Walmart or other bigger stores. You're going to see telephones on the wall, and they would be directly connected to the taxi company. Right? So that telephone would be not just for regular dialing, it would be just by the taxi company, and whatever the company would be would want to set up at a Walmart or somewhere else. You pick up the phone and you would just dial that specific company. So there'll be that telephone set will be set up as a hotline. Okay. So 911 or 911 line and or telephone set. Okay. So here's a single line connected directly to the CO line. Single line, remember, single line is just one pair, which consists of tip and ring. It's a single line, it's a POTS line, plain old telephone service line. Now, 911, it's a specific, it's when you're installing a larger telephone system or in any commercial building, you are required to set up 911 phones, and those 911 phones have to be accessible and visible and marked. Okay, what's a 911 telephone set? Basically, what happens is that the telephone system, or KSU, Key Service Unit, or PBX, Private Branch Exchange, or whatever the box is that contains the telephone system, it requires power to operate. Right? So that thing is, he's having the telephone lines coming into that box, and from there are lines branching out to the telephone sets, and everything is nice and beautiful when the power is on. If the power goes down, that box is basically just goes down. Right? None of the telephones work. Now, for the when it comes to having a CO line, central office telephone line, it's coming from the city, right? And it is self-powered. It operates independently from whatever the power is in the building. Right? So when the power goes down, that line is still alive. That's alive. It's still live. Alive. You still have a live line. So you can still pick up a telephone and dial 911 if you need to. Right? Yes, everybody has cell phones right now, but we cannot assume and count on that somebody in the room is going to have a working cell phone. Right? That goes out the window. That idea goes out the window. The company is supposed to provide in the best way that they can, that if there's an emergency, if somebody needs to dial 911, they have the ability to do so. And in the large production companies, production plants, or whatever big businesses, then you can when you somebody's coming whistling. Okay. Lost my concentration. Okay, let's get back to the topic. 911 phones. Here are sorry. Okay, I'm looking at this. like a school intercom system. I think, I'm sorry, I apologize. I wasn't looking at the, so I'm not sure when you have that, when you ask that question. So if you just write it again with the context, because maybe I'm not talking about this, but okay, write a question, an example of a hotline. Oh yeah, the school intercom system. Yes, that would be also another example of a hotline. Yeah. Okay, yeah, I'm glad you said that, because we're going to cover that as well in some depth, because servicing telephone systems is not just servicing telephone systems, it's actually servicing everything that's connected to it. And PA system is a large part of, the whole communication systems system that is installed. So 911 phones, it's a telephone that bypasses all the system. It just, the line just comes in from the outside, and it is straight connected to another line, and that line goes along the walls, wherever else, uninterruptedly, something, and it's connected right to a specific POTS phone, single line telephone set, which is just a telephone that you buy in some Canadian Tire, Walmart, wherever else. That is the simplest phone, and it doesn't require any power. You can probably buy one of those for like $5 or maybe less online if you want. Okay, and once you pick up the phone, you're supposed to get a dial tone, which brings me to another thing that I need to point out. When you have a huge facility, it's not enough to just have one, because if there's huge facility there and there's one 911 set here, and if something happens there, those people who are working there, they don't necessarily have to know that there's one there, because maybe they will never go to that part of the building, right? So it has to be, those 911 phones have to be distributed accordingly in the areas that the people are in, and they see where it is, they know where it is, and they have clear access to that. Now, remember when we were talking about the daisy chaining, the old ways of connecting the phones? It would be connecting things as a bus configuration. So you could have a line going, coming from the city. This marker is getting a little bit weak. And then you could just connect the telephones here. You could connect telephones here. All right. Now, you could connect many telephones, and as long as the system can handle it. You could pick up this telephone and talk on it, and hang up, and somebody else can pick up on the phone, dial telephone. The problem is that if this telephone is being picked up, the conversation is done, and then somebody doesn't hang the phone properly. It just doesn't go on the hook properly, or it falls off. Then this telephone is useless. You can't use that phone, okay? Because then the dial tone is going to go for a while, and then the circuitry is going to sense that yeah, the telephone is off the hook, so we cannot busy out that line, because that line can be used for somebody else, and it's just going to disconnect that line until you basically replace the telephone on the hook, and the circuitry goes back into the listening mode, right? So that means that when you install the 911 phones for any facility, you cannot do any of that, because this telephone could be somewhere here. That telephone could be somewhere completely else, somewhere else, right? So that's a no-no. In order to have proper 911 phones, you should have a line going in, and that should go to a dedicated telephone that's somewhere on the wall. If you have another one somewhere, you should get another telephone line that goes directly to that. Okay, that is something to do with the 911 telephone sets. Okay. And it is required that those 911 sets are being installed. Okay. Let's go back to the terminology here. Single line versus proprietary telephone set. We went over that in the very beginning of this lesson. Basically, what this means, some of the telephone sets are built Some of the telephones are built to work with a specific system, and that's the only signal that you will understand. That means it's a proprietary telephone set to whatever system it is. And single line is just basically a POTS line that is going to understand POTS line. And that's it. Okay? Music on hold, MOH. It's a very popular feature. As it says, it's a music on hold. When you dial the whatever the business, and sometimes it could put you on hold automatically, or it could be answered by a receptionist, and you say, you want to speak to somebody? It's like, okay, can I put you on hold? Yes. So instead of hearing silence, you're going to hear some sort of a music, and usually it's somebody butchering some sort of old Casio keyboard and calling it a music. Very annoying, okay? Because especially if you're somewhere in the mall and you're talking on your cell phone, somebody puts you on hold, you have to listen that, because when the music, you have to listen to that music, because anytime somebody can pick up on the other side. And then with the other ear, you're hearing that elevator music that's being played in the hallways. Very annoying. I think the best thing is to have those beeps. All right. Okay, these are the questions. So we don't need a number keyboard on the 911 phone when I pick up the phone. It could be set up as a hotline, but then it's associated with more costs. Usually those 911 phones are just regular telephone lines, and they are being designated as 911 phones, and you can pick it up, excuse me, and you can use it as a regular telephone. You can dial any number, and sometimes there's some requests from the telephone provider to disable long distance and things like that, right? But usually there are those regular telephone lines with the keypad. You can dial any number, but this is so just you can pick up and dial 911. Right? No problem. You're welcome. So music on hold. Okay, so when it comes to music on hold, sometimes you're going to hear the music, and sometimes you're going to hear silence and just some kind of confirmatory beeps, just to let you know that you're still connected. You did not lose the connection. Also, music on hold, MOH, is it's a business as well. Because what happens is that there are companies who specialize in producing music on hold content. What it is that there will be a company somewhere, I don't know, somewhere in London or Ottawa or China, India, or New York or whatever else. They would set up a music on hold service. What happens is that when they sell you the service, you give them information every month or every 2 weeks or whatever the setup is, announcing the specials that are offered with your company. Did you know that we have a special on tires this week? Blah blah blah. Okay, so the music on hold will have a content that is associated with your company instead of just playing a radio. And of course, it's done for a fee. So what it is basically a box. Microcontroller, microprocessor box, just like a little tiny PC, okay, well, about this size. You hang it on the wall right by the telephone system. The output of that is an audio output, and it is connected to the telephone system, which is an input that says music on hold input. And sometimes you can just connect a radio to it, or I was going to say tape deck, but MP3 player these days, okay? And it's constantly playing. And when somebody gets put on hold, that input is being activated. Now, the other side of that is connected to an RG45 and that or Ethernet cable, and that is connected to a switch, and that is routed. So it just basically has access to internet. So what happens is that the company, the music on hold company, can log into this box from outside, load the content, and log out, and the content is being put there. It's just playing as a loop. Okay, did you know we have special on whatever the coffee cups today? All right, so that's the music on hold business. Okay. Dry contact relay. All right, dry contact. How is it that the relay is working? Well, here's a coil with terminals, right? And here is an electromagnetic switch. Right? And there are other terminals here. Okay, so whenever you apply power, the current that flows through this coil causes electromagnetic field and makes that contact close. Now, what makes it a dry contact is because this is just a dry contact. There's a switch. It's not electrically connected to the electromagnet here. So sometimes the dry contacts are being used when the telephone system is connected to a paging system, PA system. Some of the paging amplifiers require a dry contact to be activated so the sound can go through. So there is an input cable connected into the input of that PA amplifier. And whenever you pick up the microphone or have some audio source, it is going to basically pass the signal through and make it go through the speakers. The problem is that if you always have this thing connected, and there is nothing going on, you're not doing the pages, that input is active and it picks up noise. So basically, you're going to hear an annoying hiss going through the speakers. So you don't want to have that. You want to have that amplifier not activated. There are two ways of accomplishing that. Some of the amplifiers are gated. So they're going to have a gate. What's a gate? Gate is basically sending up a threshold. Signal has to be certain level for this thing to be recognized as a signal, and then the amplifier is activated and the sound goes through. Or you can have a relay contact on the amplifier. So in order for the signal to pass through the amplifier, that has to be basically shorted or closed. And that's what the dry contact relay does on the phone system. It's an output type of a system, output type of a connection that goes to the input of the usually a paging amplifier. Or sometimes the dry contact can be programmed as an activator for auxiliary ringer, for external ringer. So usually that works for the night service, and we'll go over that as we go through the features. All right. Now CO line, okay, the dry contact. So we got that. PI, paging interface. We'll go over that. Paging interface is a piece of equipment that is being put between the telephone system and the paging system. Something has to either translate the signal from that one to that one, or set the levels, or sometimes the paging interface is also being used to routing the signal to different zones, because sometimes you want to do an all call, sometimes you want to page just the offices, sometimes you want to page the production hall, sometimes you want to page just the shipping and receiving. So this way, it's that people who are sitting in the offices, they don't have to hear all the pages that have nothing to do with them. It's just somebody wants to do an all-call page for the production hall. Okay, so it's signal routing or routing and zoning. So this will be called zoning. Okay, we'll go over that too as we go along here. All right, so CO line, central office line, we know what that is. This is a POTS line. Then single line, all right? It's also a POTS line. Single line and CO line, they're basically the same. They're called different ways, okay? Now, CO line, it's a single line coming from the central office, and single line, it could be a telephone line in a single line format, which would be just like a CO line, but it must not necessarily coming from the CO central office. It could be coming from the PA system, no, from the telephone system. Okay? Rollover telephone lines. I have to explain this this concept to you. Let's say we have well, somebody requires, there's a business that requires 1, 2, 3, 4. Line 1, line 2, line 3, and line 4. Because they have so many employees on the floor or hired, and they figure that if they purchase 4 outside telephone lines, it is enough for people to be able to always get a line. Okay, so that will be 4 lines. That would be maybe 10 people in the office. Not all 10 people at the same time are talking to the outside. So the proportion of the telephone extensions and the CO lines kind of works out. If you need more, maybe there's a call center or something else. Yes, you need more lines, right? But just a regular business, the proportions are usually you need less lines than there are people on the there are people hired. Okay, now you need to publish your main telephone number to the outside. So you're not going to publish, because every single line has a distinguished telephone line, assigned telephone number. Right? So let's say this could have a number 455 2356. Okay, 455 1234, 455 1235, 455 1236. Of course, would be like 519 our area code and so on. So every single line has a separate number. Now you decide which one, and when you purchase the rollover lines, you're going to decide which telephone number to publish. Phone book in the old days, now Yellow Pages or Google or whatever on the website. You don't want to publish all phone numbers because that will be confusing to the client. You just want to publish one of them. But if those 4 lines are included in the rollover sequence, it doesn't matter which telephone line you call, the telephone call is going to come in on any available line that's available. So let's say somebody in the office is talking on this line, and this is the main published line, for example. You chose to have the line 1 to be the main published line. But somebody is talking in the office. This line is busy. Somebody is talking to the outside line. Somebody else from outside dials this number. This phone call rolls over to the next one. So this line is going to ring. If this line is busy, then this line is going to ring, and so on. And if this line is busy, it's going to try to ring this one. And if it's free, it's going to ring on that. If it's not, it's going to ring on that. So it's a rollover sequence. Okay? They have to be specified. They have to be set up at the central office that there's a rollover sequence. Here's a main published number, and this is the one that you publish, and this is the whole rollover sequence for that company. Okay, so that's the idea of rollover lines. Right? Now, also, what that means that if somebody, well, there could be a receptionist or somebody in the office, they could have buttons on the phone labeled line 1, line 2, line 3, line 4. Right? And if you want to select line 2, because you could basically have an indicator that, okay, line 1 is busy, you want to call outside line, you press line 2 button, you get line 2. You dial outside, and somebody receiving on their cell phone is going to have a telephone displayed, but not the one that you're calling from. It's going to have the telephone displayed that is associated with the main published number from the rollover sequence. Okay. So this is important to know, because sometimes you need to trace the numbers. Yeah? And when I showed you something that's called a BICS clip, and you basically would have the BICS clip, and you would have a either BICS clip, or you could just tap in to a telephone line at the in the communications room. You dial the outside number, you dial your own cell phone number. It's not going to tell you the number of the line that you're calling from. It's going to tell you the main published number. So that will be a problem. You cannot be doing that, okay? Because then sometimes you need to find which line it is that you need to add to the phone system. Let's say somebody ordered 2 more lines, and the Bell Canada or AT&T or whatever other company or TELUS, they would just install those lines. They'll provide those lines. But sometimes the label falls off, or and sometimes you need to just find out where that line is. And I'll show you what to do when it comes to this type of stuff. All right. So here's the rollover sequence. We're going to come back to the line tracing. PBX, Private Branch Exchange. Okay. It's a telephone exchange. Telephone exchange is a box that does all the signal routing, does all the telephone line exchanging. Right? It's a telephone exchange. So it could be a central telephone exchange from the central office. You have a big central office telephone exchange, the main branch, or you could have a mini telephone exchange, private. What was this thing here? PBX, private branch exchange. Okay, I'm losing the words here. So you can have a mini central office set up at your business or whatever the business is, the other facility, and that's going to basically look like a mini central office. But just to distinguish that, it's a PBX, right? Private branch exchange, or you can have something that's called KSU, which is key service unit. It's the same thing. It's a box. Usually private branch exchange are associated with bigger KSUs that you could say in the hospital, you have maybe 500 extensions there or 600 extensions. You would have a tendency to call that PBX, private branch exchange. But if you have this little tiny telephone that services 8 telephones and gets 3 incoming lines, you would usually call that thing a KSU, key service unit. Right? All right, now here comes to the ELEC number. Right? It only works with the CO lines, and you have to know with the regular telephone lines, CO lines, it only works with the telephone lines that are provided as in a POTS format and that are provided by certain provider. So like, for example, Bell Canada, it does have an ELEC number, right? And it's like this. Now you dial the area code from whatever you are. So we are sitting, like for example, we're sitting at area code 519. It could be 226. So you might want to give it 519 or 226. So in the beginning, you dial that area code that you're in, and you dial this number, 958-2580. Notice that I do have this thing written down on my butt. Right? Just so I don't forget that. And those 2 brackets, they say it's it's area code. Of course, you're getting this thing displayed backwards because I'm filling myself. I have to film myself backwards because when I write text, it has to appear the right way. So when I show something like that, it's going to appear backwards. All right. So I have that thing. So if I want to trace that number, and if I called it ELEC number, right, what does the ELEC stand for? Let's see. Automatic number announcement circuit, ELEC number. Right? So I can tap in to this line, which is part of the rollover sequence, and I dial the ELEC number, and it is by voice, it's going to enunciate the number I'm calling from. Not the main published number, but the particular line. So that you're calling from. Now, if you don't have the ELEC number wherever you are, you could be out of luck a little bit, right? So sometimes when you're doing a service call or installation, you're going to request that the lines are labeled properly, and if they are not labeled, there's nothing you can do, right? Then you just go back and tell to the client, look, get the whatever the installer that came from the building, from the company, and get them to label those numbers, right? But if there are POTS lines, you can use the ELEC number. All right. Okay, so here is 1 o'clock. Let's take a quick break, and we're going to continue uh, with these conventional telephone systems, and then we're going to switch into VoIP, which says Voice over IP. All right, how many minutes? We get 7 minutes. So okay, so let's say 8, because that thing is going now. So on our telephones, 8 minutes after 1, we come back and we continue. All right, go and get your fresh coffee. Okay, we got the sound again. Can we hear me? Yes, no, yes, good. All right, so we're going to continue. I'm going to queue up to that slide. Oh, here it is. All right, so we're going to continue with this. Not much left here. POTS, KSU, Key System Unit or Key Service Unit. So we just explained what that was. POTS, plain old telephone service, which are basically it's a service that is associated with regular telephone service signal provided from the central office or from the city. Yeah. Tip and ring, we covered that in the previous lectures. ATA, analog telephone adapter. Here it is. All right. We need to know what that is. All right. So let's say you have a certain type of telephone box or box that's servicing as telephone system or KSU. All right. Do we have better? Okay. KSU. Can we see this? Yes, we can. This is a better marker. So here we have KSU, and it has a certain type of signal that basically from here it goes to the telephones, different telephones. All right, here. Now there are lines coming in, and so on. Line 1, line 2, line 3. So that's a KSU. This is the whole brains of the telephone system. Now the extensions can be connected. The extension connections can be connected to a proprietary telephone set, or it could be connected to something else, because that over here is providing a proprietary signal that is only understood by the telephone that is designed to work with this KSU. Now, when you have other peripherals, such as, let's say, paging interface over here, paging interface, PI. From here, it can go into an amplifier, and from here, it can go to speakers that are distributed along the facility. Now, the paging interfaces usually are done by other companies that have nothing to do with this company that produced this telephone system. So the paging interface is looking for POTS line, usually, okay? POTS type of a signal right here on its input. But this one is not providing a POTS signal, it's providing a signal that only is understood by these phones. So we need to have something in between these two to translate the signal from whatever that is into the POTS telephone signal. And that's where the ATA comes in. Elephant, analog telephone adapter. Okay. Now, over here on the output of that is a POTS type of a signal. And over here that it connects into the KSU, the signal is being understood by this ATA. Now, the ATA is also produced by the company that has produced the KSU. So that will be the same sort of from the same brand. Different ATAs work with different systems. There's no one universal ATA. Okay? So if somebody wants to dial, or somebody from this phone, they want to do the all-call page, they pick up the phone and they dial the feature of, let's say, paging. So then this whole thing understands that, connects that to this, whatever it's programmed as, or you can actually, this ATA could be actually assigned an extension. So this would be extension, maybe, let's say, 216, 217, 218, and this could be a 222 extension. So if you dial that extension, it is also possible, if that's the way it's set up, then the ATA is going to pick up and is going to give you a confirmatory buzz or a beep or some sort of a tone saying that it's waiting for the input. All right. It could be set up that way, or it could be set up automatically that as soon as you dial that, and it just basically it's going to dial the paging interface. Paging interface is going to sense the ringing tone, and it's going to connect you to the PA system. Or if you have different zoning set up, you could have different amplifiers, or you could have an amplifier that services different zones. This could be set up in a different ways. But let's say you have separate amplifiers that go to different type of speakers, okay? Different zone, okay? So this would be production hall, for example. Production. This would be offices. Offices, okay? So it could be set up that once you dial the feature of paging or dial the extension, depending on how this thing is programmed and set up, you are going to have like a tone. So yeah, ATA has picked up. It usually sounds like beep, okay? And then the staff that works for that facility has to be trained to understand what that means, all right? So once someone hear the beep, in this case, you would select zone 1 for production and zone 2 for the offices. So you just press 1 or 2, and that thing routes the signal to wherever it has to go. Right? So here's the ATA adapter that converts a signal from the proprietary KSU or the telephone system into the POTS line. Right? Now, also it could be connected, it could be another ATA connected to something that's called auxiliary ringer. Right? What auxiliary ringer is that it could be programmed that this ATA is going to sense that, for example, this telephone rings, and as soon as this telephone rings, you're going to make that ring as well. And that would be a box with a loud ring, or sometimes they have strobe lights connected to that. Where this thing is being used is maybe there's a production hall and there's a supervisor's office on the production hall. So for the night shift, the supervisor will sometimes just goes and works with the other workers on the line, and somebody wants to connect, somebody wants to get a hold of the supervisor, then the auxiliary ringer is going to kick in during certain times of the day. It could be programmed that this thing is going to ring from, like, say, 8 p.m. till 6 a.m. or something like that, right? So so that could be mounted right on, basically by the door, and it would produce a loud ring and sometimes a strobe light or so on. Also, what it could be connected to is another extension, could be connected to another ATA, and could be connected to a regular POTS telephone, just a regular telephone set, single line telephone set, right? Where that is, sometimes those also are being installed in the lobbies, so when or lunch rooms and things like that. So that also is an option. Or sometimes those, it could be not a telephone set, it could be a something like called a door station. Oh, we're running out of space here. Let's say another one could be another ATA. And it could be connected to a door station. A door station looks like this. Here's the speaker set, and here's maybe a button to press. And it's just like, it just looks like this. And you mount it somewhere. Quite often it's being mounted. It could be also done in the lobby. at some point, those door stations were being connected in the elevators, but then quickly somebody reflected on that. You cannot have that connected to the KSU, because if the power goes down and someone is stuck in the elevator, then you cannot have that going through that, because if power goes down, this thing goes down as well. So there will be the elevator phone or door station, in short, but that has to be connected straight. And it's a different type of station or elevator station that has to be connected to the outside line, so it's independent of the power in the building. And of course, if it's an elevator, it's set up as a hotline. You press the button, there's no handset, you press the button, and if it's set up as a hotline, it just goes and calls specific number to the elevator service company or whatever else. Or sometimes there could be the door stations are mounted at the track entrances. So if there's a huge facility and they have gates for the trucks to roll in, and somebody has to open the gates for them and receive those trucks, those would be installed right by the elevated, so the truck driver can just roll down the window and press the button, and this will be connected maybe to the supervisor. So it also will be set up as a hotline. Okay, so ATAs basically, and then that is acting as a single line set. Single line set is acting as a single line set, or like a POTS format. Paging interface is looking for the POTS line format. So, so ATA is a telephone, analog telephone adapter. Another very popular way of having the ATA adapters is, let's say sometimes you have a, in your home, you order a dry loop. Remember what dry loop is? It's a telephone line that provides only an internet signal. Right? It's no voice. And sometimes you have something that's so-called internet phone. Yes, you have the telephone, but the telephone doesn't go through the regular telephone line. It actually is, but it's connected instead of the CO exchange, the central office. It goes to the it connects to internet. Okay? So sometimes you get those. Of course, they are not going to call that ATA adapters because it would be confusing for the regular consumer type of a person. They're called the telephone box, and telephone box is nothing else than an analog telephone adapter. You get that thing connected to your the input of the ATA. It's connected to the router, and it understands the internet signal or the Ethernet, and then it connects to the internet through the router or a modem. And on the other side, you have a regular telephone. So if somebody calls you, the telephone signal goes, the telephone connection goes through the internet, goes through your modem, through your router, connects to ATA, and ATA is having just a regular POTS service, and it's just going to make your regular telephone ring. So that's the idea of the ATA adapters. Okay, let me just erase that this whole thing here. Erasing that glass board can be tricky, but I found a way. All right, let it dry. So here is the ATA adapter, analog telephone adapter idea. Right? Battery present. What does that mean? It's a technical jargon used by the telephone technicians or people who are associated with the telephone systems. Remember when I said that the POTS line is self-sustained. It has its own power and is getting the power from the central office. And remember, it sits at 48 volts DC. In order for this thing to ring, now there are different formats of a signal. Basically, it has to be brought up to 90 volts at least. If you bring that to 90 volt DC, it is going to start ringing. Now, sometimes you're going to see different type of signals. You're going to have like a 90 volt AC riding on the DC and so on. But the basic idea is, as soon as you bring it up from 48 volts DC idling, if you bring it to 90 volts, that telephone, it's going to make that telephone ring. So here's the, oops, that's not this one here. Here I am. Here's the idea of the battery present. That during the idling, when the telephone is not ringing, there's no conversation happening, it's just sitting at the idle state. 48 volts, it is connected to a battery terminal or DC power supply, and in short, it's called a battery. So sometimes you can, during a service call, you can say, okay, you can say the battery is present, but there is no dial tone. What is the word in the brackets beside the battery? Oh, sorry. Okay. Battery present. Yeah, it says battery present. In the bracket, it says present. Yeah. So it's a basically it says 48 volts present across tip and ring. So basically the idea is, yeah, there's a DC signal supplied, but there's no dial tone. So the circuitry at the central office has many plug-ins, if you will, physical plug-ins, and some of the equipment provides the DC signal, the DC power to the telephone line. The other one adds the dial tone onto that, and so on. So usually, when you have a regular POTS line, you pick up the phone, you should hear a dial tone. If it's supposed to work as a POTS line with the voice capability, if you don't have a dial tone, other than it being a dry loop, you're not going to hear a dial tone. But if it's not supposed to be a dry loop, if it's supposed to be a voice line, yes, you should have a dial tone. Right? So you can say, okay, battery is present, but there's no dial tone. So you can tell the client, okay, you know what? There's nothing you can do here. We gotta call the service provider because something went wrong with their circuitry at the central office. Right? So that's the idea of battery present. One way of, if you have no equipment whatsoever, here's a nice way of telling whether it's a battery or not. If you just want to do a quick check, you strip the pair, so you have two bare copper tips, all right, or tip and ring, but you have two bare copper endings. You make a finger wet. Usually, you can just use your own saliva here. You can make a finger wet and just put those two lines right beside each other. One of them is going to start foaming. That means the DC is present. It's a trick. Okay. All right, and then there's a last word that says a trunk, just like the car trunk. Multiple telephone lines physically bound in one cable. It's half true, okay? Because originally, a trunk would be, a 25 pair cable could service as a trunk because it would be many single line telephone lines bound in one jacketing. Right? So it's a trunk. It's servicing one sort of area there. Now, when it comes to digital trunking, you could still have a one pair, but the lines would be solved by assigning a certain bandwidth to the lines. These are called SIP lines, and we'll talk about that when we talk about the VoIP. So trunk basically is a signal route or signal conveyor that is capable of providing multiple lines. Originally, it was physical cable that contains many lines and bound in one, and it's servicing one area. Now, of course, you can also solve it as a bandwidth. You will have one pair, and you could solve the frequency division multiplexing way, okay, the frequency division. So you can have different channels that are associated to different telephone lines. Okay, so it's a trunk. Right, so here goes that slide. All right, let's keep going. Now, what do we see here? Over here, and I encourage you, of course, to watch the lab 6 part. It's going to explain to you how the BICS platform is solved. So over here, we have the BICS mounts, all right? And over here, we have a bunch of 25 pair cables going in, and they're being terminated on those. And lab 6 is going to be us terminating those one 25 pair cable terminating on one BICS frame or connector. So here's 25 pairs, here's 25 pairs, here's 25 pairs, and so on. This frame here by itself, this bracket or this mount, holds 10 of those, which means it is capable of supplying 250 pairs, just that. Here's another 250 pairs. And over here, you have the field wiring that there would be another bunch of 25 pair cables going on. So this could be something like communications room in a big mall, that you would have different lines coming in, and this would be a huge mall, all right? So let's, for example, you have a bunch of telephone lines coming in from the city, and this one would be, it looks like it's a secondary demarcation point. A demarcation point is basically a point of entry. So it would be a secondary demarcation point, because usually you would not have that coming from the city. You would have 100 pair, bunch of 100 pair cables instead of a bunch of 25 pair cables. And 100 pair cable is 425s in one jacketing. But let's say this is coming from the city, from somewhere from the main demarcation point. And then it is those lines are being distributed here. And over here, it's so-called field wiring. So for example, this 25 pair cable that's terminated on this connector, it could go to one store that is in a mall. It would be a bigger store. And you would have 25 pairs designated by that cable that you could connect into that store. Not all, sometimes not, most of the time, not all of them are being connected. But let's say you need just 12 telephone lines going to that store. So you would use something that's called a cross-connect wire. You terminate the 25 pair cable at the front, and then you flip it so this thing goes at the back, the terminated, and you can grab those pairs from the front. And you just use the cross-connect wire to punch into that pair, and you would run it along here, and you would punch it or connect to whatever the connection is supposed to be going to that store. And from that, once that you go to the other side of that cable, wherever it goes, you can grab that pair over there, and you could use that telephone line. So as to plug into the whatever the telephone system is, or whatever it is that you're plugging it into. So that's the idea of cross connecting. You bring those here, terminate that. These are the incoming lines. This will be the field wiring. Field wiring is the wiring within the building. And then you would use the cross connect wire, pair by pair by pair by pair, and you could connect that. So this is the idea of cross connecting using a BICS platform. And BICS is usually associated with telephones. However, now there are BICS platforms that can accommodate Cat5e, but it will look a little bit, well, quite a lot different. All right, now here is the 25 pair connection. This is what we will do during lab 6. So please watch the demo. Now here is the connector that you can grab the pairs from and use the cross connect wire. You see, they are terminated. When you terminate that, you flip that connector so the back is at the front, and that's when you do the termination and punching. And once you've done that, then you flip it so that thing it's at the back, and you grab those pairs from the front here and use the cross connecting wire. Now over here, you have something that's called Rg21x standard cable connector. It also goes on to the 25 pair cable, but it's terminated slightly different. This is what you plug in to the telephone system, because the telephone system could just have one outlet like that, and you would use this type of connector, just plug that in, and you get the other end of the cable, and you terminate that on this type of a connector, so you could do your cross connecting. And those RG21 connectors, they come in female or male version. So you could also extend a 25K pair cable. If you just want to extend one, you terminate that one end on the female and the other one on the male. And you can basically plug one to the other, and you have your cable extended. Right? You'll be able to see it more clearly once you download the PDF version of this presentation here. All right, so this is what the Rg21x connector looks like. And this is something that's called a butterfly tool. And over here, once you downloaded the PDF version, you'll be able to click on that, and you're going to have a video from YouTube, I found, of how this thing is being terminated. This is just one of the millions of videos using the butterfly tool. The butterfly tool is designed so you could have it in the box and you could have it in your service vehicle. So you could terminate, because sometimes those cables, those 25K cables, you can order them pre-terminated from the distributor or whatever you're buying it from, and you could order them with one end already being terminated on the something that's called Amphenol connector, which is basically RG21X or RG21 connector. And then the other one is just a loose end, and that's what you terminate and punch on the BICs. Okay. All right, so this is how this thing is done. Those used to be expensive. Now you can pick it up on eBay for about $50 sometimes. All right, so this is the idea. Here is the KSU. Here's the RG21 plugged in, and here's the other end, and you cut it to length, and you terminate that on a BICS frame, the BICS distribution frame. Tip and ring and other connectors. We went over that. This is just a repetition from the other lectures. Early telephone exchange looked like this. It will be a manual telephone exchange. Later on, when you see the dial comes to town that I sent to you over the other lectures, then those manually switched telephone exchanges were replaced by automatic routing. So the telephone system, the telephone call would not be connected by a human, but would be just connected by equipment. All right. So that's what it looked like in 30s and 40s. Now, tip and ring, any musicians, guitar players, we talked about that. This is the 1/4-inch jack, usually still used by musicians to plug things, cable in the guitar. This is the type of outlet you have, and there are two types of, you usually have tip, ring, and sleeve. All right, so here would be the sleeve, number one here, that would be the sleeve, and that would be the tip and ring. Sometimes you can just get just a tip and ring, so this would be tip and ring, and that's it, there's no sleeve. Or sometimes you just have tip, ring, and sleeve, then you will have the balanced signal, and we already talked about what a balanced signal is. Okay. So that's why when we talk about telephone line coming in, we're not talking about the plus and minus or connector 1, connector 2, or wire 1, wire 2. We're talking about a tip and ring, and that's where it originates from, because of those manual telephone exchanges in the early days. These would be those jacks right here that the telephone operators would use. So that's why we have tip and ring. Okay. Here's a repetition of the other things. So we already talked about that. Tip and ring. Remember, tip is neutral with reference to ground, and the ring is more negative, and it sits at 48 volts, and it's going to make it ring at 90 volts. Now, here's ATA adapter. They look sometimes like this, and sometimes they look a little bit different, depending on what company, for what system they make. The new Cisco ones, they look like this, and they have inputs. And this will be the telephone box that is in your home if you have your phone through internet. Okay, so one of the ports would be connected to the Ethernet, and the other ones would you just have regular telephone outlets that would work with the single line sets. Again, this is what auxiliary ringer looks like. Sometimes it just makes a lot of noise when it rings, and sometimes it's also flashing a strobe light, or sometimes it's just a strobe light. It depends on how you want to set up, and there are different kinds made by different companies. All right. What do they say here? Peripheral devices. While designing a system which involves interfacing an ATA and other peripherals devices such as paging interface or loud ringer. Confirm. So if you connect, basically we'll say, if you're connecting other devices to the system, confirm the specifications of all devices involved. Different devices can be made by different brands, bearing different input and output levels. Best thing, read the specs and confirm in practice. This can save you a lot of time and aggravation, especially while designing a larger system involving purchasing and installing multiple devices. What I'm saying by this is that ideally an ATA adapter should be sensing the signal from whatever the telephone system is, or whatever the telephone system, okay, or internet or Ethernet, and it's supposed to supply a POTS format, signal in the POTS format, which would be just a single line, one pair, tape and ring. That's the output. And then there would be a paging interface that is supposed to sense that. What I'm saying is that not all ATAs are made equal. Different companies have different standards, and sometimes they would just do it and test on one piece of equipment and not testing on all the other ones. So sometimes you're going to run into problems that, yes, everything is connected properly. The telephone system is recognizing the ATA. Yes, it's going to ring a regular telephone set, but sometimes, for some reason, it's just not triggering the paging interface. Right? Unfortunately, there will be cases like this, and you can lose a lot of time saying, okay, verifying your connections, verifying your connections, verifying your connections. Sometimes it's just that the ATA adapter made by whatever the company is not putting enough signal to trigger that, and then you have to address that, usually by contacting one company and contacting the other company. And sometimes what happens is that they would have one ATA adapter, and maybe a year later or 2 years later, they're going to come up with the same ATA adapter, but they will have a different model, upgraded version or something like that. And they also tweak with some of the signal levels. And yes, the one that's 2 years old works with that, and the one that's brand new, it doesn't want to trigger the the paging. So I'm just giving you a heads up that you might encounter that type of a problem sometimes. Eh? It's not you, it's the equipment. Okay, so now here is something that's called a paging interface made by Bogen. Okay, do I have another? No, I don't. That's what the paging interface looks like, and it's modular, and sometimes they're as complicated as this, and sometimes they're less complicated. So this would be a part that you connect your telephone POTS format right into the ATA adapters, and over here there will be different signal routing and so on. Once you get into the business, you're going to get those, and you're going to get documentations with that. And don't worry, in the beginning nobody's going to throw one at you and just go and install. All right, you're going to be accompanied with another person who already has done this type of thing, or if it's a brand new thing, yes, there will be a telephone for the support, the technical support for one and the other. And sometimes if you do it for the first time, you might have to spend a little bit longer time on figuring this out. And then once you've done it once, then you're going to just keep going with it. All right. So that's what the paging interface looks like. All right. Now you saw color codes. We went over that. Just a repetition, tip and ring, remember, in two middle prongs. And this is how it corresponds to the modern version of the USOC, Universal Service Ordering Code. We went over that, but I just wanted to throw that in. So if you're only looking at this presentation, you should see some, you should have some referencing. Outlets or jacks. I have to head out. Okay, okay, so now I guess we're going to have to spend another lesson on the VoIP, because there's no way we're going to be able to cover that. Okay, so I'm just going to keep going with this until the full hour. And if you have to go, please, by all means, go to another class. You will be able to visit these presentations on YouTube once this thing is being posted, and it's going to be posted very soon, minutes after this thing is done. So, okay, if you have to go. You can just you can watch the rest of it when it's posted on YouTube. All right, have a good one. All right, so outlets and jacks. These will be the surface mount telephone jacks. This will be the wall mount telephone jack, and this will be the modular. So you see those RG45 jacks, they are designed to handle the Ethernet signal. Will it be Cat5e, will be Cat6, Cat6a, and whatnot, all right? But they can also be wired as telephone jacks, and the telephone cord will plug into that. They're made in that way. You cannot go the other way. You cannot just have just a regular telephone POTS jack and use it for Ethernet. It's just not made that way. It's not going to pass the signal properly. The signal is not going to be understood because it will just trip over its own feet when it comes to this type of wiring, right? So, so that's the type of outlets and jacks. Connectors and plugs. RJ11, you can see 1, 2, 3, 4, or RJ12. Basically, it's the same size of chassis, but RJ11 doesn't have, it just has 2 pairs. RJ12 has 3 pairs, okay? And that's what the telephone cord looks like. And then there's the RJ22, which is slightly thinner. It's slightly smaller in size. This is the one that plugs into the handset. And of course, here's RG45. This is the one that we have already terminated during our lab 5 or 4. I think it was lab 4. Okay, whichever the lab was. It was the RG45 T568A or B. Okay, so these are the jacks, and RJ stands for registered jack, of course. Connecting it together. All right, so here's a printout from the telephone system that we had in the beginning. This would be the pairs. You see, there's 25 pairs from 1 to 25. And there will be colors. There's a white group, here's a red group, here's a black group, here's a yellow group, and here's a violet group. And every group has blue, orange, green, brown, slate, blue, orange, green, brown, slate, and so on. The group colors stay the same every 5 pairs, and every group has blue, orange, green, brown, and slate. Slate stands for gray. Okay? So here is the list of pairs. So pair number 1 is white, blue. Pair number 2 is white, orange. Pair number 3 is white, green, and so on. So here's the colors, and this is what it corresponds to this type of jack right here. Let's go back here. This one here, all right? So this will be the pairs that are associated with that. That's how they are terminated on this jack, and they correspond to the number of pairs. Here's pair 1, pair 2, and pair number 25 at the end. And over also here, they are specifically installed. So pair 1 is pair 1, pair 2 is pair 2. So correctly, it needs to be wired correctly. So pair 1 actually terminates on pair 1 here, and so on. So here's a pinout. When you go to, let's go back here. When you go to terminating on BICS, this one here. So pair 1 on this phone system would be what? It's not fast enough. So pair 1 would be station 1 with just the telephone extension. Station 2 and station 28. So this is the one that's 8 by 6, 6 by 16. So you have 6 lines coming in, and this will be the output of the BICS. So 1, 2, 3, 4, 5, 16 extensions. You can connect 16 proprietary telephones. Now these are not used, and here would be the external paging audio. So this would go. This would be the signal that goes to the input of the amplifier. Over here, the pair number 23 would be external paging contact closure, which would be the dry contact relay. So sometimes it's required. So it could be usually by default, this pair is associated with that. When you make the page, the relay contact closes, to activate the amplifier, which we talked about. This would be auxiliary ringer contacts. Some of the auxiliary ringers, they don't connect through ITAs. Most of them actually connect right to the power outlet there. So they got a little power transformer and they get power from that. And as soon as you close the contacts, it rings. So that can be programmed, this pair can be programmed to be associated with a telephone or with a line. The programming of that is quite flexible. Yeah. So when it could be programmed to be activated when a specific phone rings, or could be programmed when a specific line rings, or it could be programmed when there's a group of line, any of the group of line rings. Yeah. And of course, here's the last one here is the music on hold. And so here will be external paging audio. This is the output. This is a dry contact closure. So it's an output, okay? Then there will be auxiliary ringer contact. It's also an output. Now here music on hold is an input. So sometimes you can just get a radio or MP3 player and just get the signal out of the headphone jack, wire it into here, and or you can have the music on hold device provided by the third company. All right. Now connecting it all together. So here would be a telephone system or KSU or PBX, private branch exchange, and in this particular one here, you have just a regular RJ jacks. So you plug in regular telephone cords into this, and that's how you grab the incoming lines. And then over here, here's the BICS platform, right? So from that Amphenol connector or the RG21, those are being brought in, the pairs are being brought into here. And from here, you can connect that to voicemail box. Some of systems have a separate voicemail device to be associated with that. From here, you can connect this to ATA adapters. Those adapters can be plugged into the single line telephone set, or could be a door station, which we talked about. There could be auxiliary ringer contacts based on whatever the pinout that we had last page. It could be auxiliary contact, or you can have all the stations connected. Then one of the extensions can be connected to the ATA adapter, and that could be connected to the paging interface, and the paging interface connects to the paging amplifier, and the paging amplifier connects to the speakers. So you can have the all-call pages or the general announcements using the telephones by pressing the feature or dialing the extension, depending on how the system is set up and programmed. And of course, here you see, I just put that single line set. It's a 911 phone, it just hangs on the wall. So these lines are coming through the KSU, and that one last line, it's bypassing everything. It goes straight to that, right? Okay, so we're going to have to, these are the references. We're going to have to carry on with the VoIP during the next session. So yeah, I thought I was going to be able to do both, but I need to give you the basics. So when we talk about VoIP, it's going to be a shorter lesson because I'm not going to have to go to the basics that I gave you during this. So a lot of the features are going to be translated into the VoIP, which is voice over IP telephone systems. It's just things are being set up a little bit different. But same thing. The idea is you pick up the headset, you talk. Okay, you can transfer the calls, you can put calls on hold. But I need to show you in the next session. I need to show you the VoIP system or the VoIP setup because it's the latest hot thing that's going on. A lot of the companies are switching from the POTS service into the VoIPs, but in order to be able to switch from one to the other and make a proper connection, if it's a small business, then there's no problem. You just do a few connections. But if if you have to service a company that has 300 telephone sets, and some of them are in the offices, and some of them in production hall, and some of them are here and there, and there's different wiring. So I need you to know what one is, and I need you to know what the other one is, so you can combine the two pieces of information together and make sense out of that. All right. And of course, if anyone wants to know more in details, talk to me during the labs, or if you see me walking on the hallway, or send me an email if you have any questions, if you're interested in that. All right. Okay, I have to head out to have a, okay, have a good day, Adam. All right, and have a good day, everybody, and have a great weekend. And I will see some of you during the lab, and some of you, everybody is going to see you in a week. All right, thank you. Have a good one. How do I stop this thing? Oh yeah, it's a different mouse.